My name is Nakangu Teddy, Computer Science at Phi-3 University, and I'm going to be taking you through our graphics project, which is under the topic AI-driven visual story-based learning for accelerated refugee education. That is to do with fine-tuning multimodal models for Uganda's competency-based curriculum. And I'm from Group 4. Then under this, we have some keywords. We have competence-based curriculum, which is an approach that focuses on mastering specific skills and competencies rather than just covering content. So students, in this case, students progress by demonstrating their understanding and ability and not just time spent in class. Then we have generative learning technology. That one is, these are just tools that create new lessons or explanations. These ones, they help personalize learning and also adapting materials to reach the learner's level. Then we have interactive storytelling. This one's just a method that uses stories with user participation to enhance engagement and also learning. So it makes learners make decisions that affect their story outcome. That improves their critical thinking and even retention. Then we have multimodal artificial intelligence. And these are just systems that combine multiple layers of data, texts, images, that is audio, or even videos to understand and generate outputs that are richer. Then we have refugee education. This is just education designed to meet the needs of displaced learners, those who face barriers like interrupted schooling, language challenges, or even lack of resources. Then last, we have vision language models. Those are just advanced AI models that link visuals and textual understanding, and they can interpret images, describe them in words, or even generate images from texts. So these are some of the contents in this presentation. They are listed down there. Then with the background, we know that Uganda hosts many refugees, and most of them are enrolled in accelerated education programs, one I defined earlier. So this program struggles with limited resources, one. Then it also has a challenges with the languages since learners come from different countries and different states. Then there is also a challenge of trauma-related gaps. So that is where this project comes in, to introduce an AI-driven multimodal content authoring system that replaces manual 3D designs with visual language and generative models, for example, Unity or even Blender. So it is concerned with fine-tuning large vision language models, for example, the Phi 3.5 Vision, the Stable Diffusion, Google text-to-speech, and more, that generate culturally relevant data or lessons that align to Uganda's competence-based curriculum. So the outputs include interactive scripts, storyboards, and even 3D animations that are lightweight, all can be used in low-resource areas. So this approach, it enhances engagement, life skills, and also directly supports quality education, peace, and justice. Then we are able to view some works, and this table lays out some of the papers that we're able to review, the models, their years, and basically recent years, their contributions and limitations. Same as this one, it talks more about the related literature. Then for the problem statement, for the domain application problem is that refugee children in Uganda, they lack access to high quality localized learning materials that could help them smoothen their learning. And the existing materials in accelerated education programs, most of them are outdated. They're linguistically misaligned and also maybe unavailable offline. And then with those, there is also an issue that there are limited devices, which worsens the educational gaps in these areas. So some of the computational problems we're looking at, one is curriculum aligned content generation. And here we are looking at generating lessons that are mapped to Uganda's competence-based curriculum, which focuses on the learners' understanding and skills rather than the content they get in class. So this ensures pedagogical accuracy, competence alignment, and also structured learning flow. Then another problem we look at is multilingual support. This one integrates different languages like Luganda, Kiswahili, English, because we all know that the learners in these areas of settings, they come from different countries, so they'll be speaking different languages, so which becomes a challenge to communicate with their fellow learners or even their teachers. Then we have another challenge, which is cultural adaptation. So with cultural adaptation, this one is to do with embedding local stories, symbols, or even culturally relevant contexts, that is with the stories and the visuals that promote language inclusivity and better comprehension. Then we also look at offline and low bandwidth optimization. And in here, it is concerned with applying model quantization, like pruning and even basically creating a system that can be used in low resource areas, all deployed in such areas like the refugee camps. So this would enable offline learning in these areas that are in that kind of setting. Then we have research questions and objectives, and some of the questions we ask ourselves is that how can graphics-based content authoring framework support CBC-aligned learning in refugee education? Then what methods can generate multilingual, culturally adaptive, interactive learning modules that function offline, all in low bandwidth settings? And then how effective are AI-generated graphics and interactive content in improving engagement, comprehension, and related refugee contexts? Then lastly, we ask ourselves, how can open access visual learning objectives and templates be designed for scalability and reusability by the educators in those settings? Then some of the research objectives we have is to develop an offline fast modular graphics content authoring framework for CBC aligned learning modules. So another one is to create animated and interactive learning modules using lightweight all open source platforms. Then the other one is to evaluate learners' engagement, comprehension, and retention in refugee education settings. And lastly, to produce open access visual learning objectives and templates for educators and to adapt and scale. Then some of the research contributions is that we developed an offline fast modular graphics content framework for CBC aligned learning modules in low resource refugee settings. Then we created animated interactive and culturally adaptive learning modules using lightweight platforms with multilingual support, and then evaluated learners' outcome, including engagement, comprehension, and retention through field trials and refugee schools and learning centers. And last, we created reusable visual learning objectives and authoring templates for educators. So these contributions are not fully complete, but still in progress. Then this is the methodology that we're following and pipeline for this project. First, we have input that is passed on to the curriculum mapper, and then we achieve a curriculum aligned prompt, which is then passed on to a story and script generator that goes through the embeddings and encoding to receive a script draft, which is then passed through GRAG and to obtain a culturally augmented script, which is passed to the text encoder to extract text. This encoder then passes its output to the denoiser that does its work, and also to the storyboard generator to generate storyboard frames. And after this do their work, we obtain a storyboard frame, we obtain a narrative audio file that are then passed to a video composer where it is sequenced and translated, and then we obtain a synced video clip, the one that syncs audio with the actions. And then we are able to generate an instructional video at the end with that pipeline. Then with the data set description, first we source the data set was extracted by we ourselves as a team from Uganda's Competency-Based Curriculum PDF under the Accelerated Education Program. We basically looked at mathematics for now, and then for this data set, it has 26 topic levels, and that is for level 1 and term 1. And the target variable here is basically the competence, which defines the key skills and ability learners are expected to acquire. Then some of the features, it has 13 features, which are outlined on the slide, including the subject, the level, the competence, duration, and many more. So with that data set, we are able to do some exploratory data analysis to understand the data, and we're able to visualize the distribution by level and then distribution by competency. This one tells us the length of the characters, of how many the characters that we can include in a text, let's say the prompt. Then we're able to visualize the distribution by level, and then the most frequent topics. That means that there are topics to be worked on, it's not empty. Then the portion of topics by duration, which tells us like how long our scripts can be, the videos can be. Then we did a correlation matrix that tells us how the flow of the data that we are working with. Then with the results, when we ran our models, we're able to generate some images and audios, and at last a video. So which are some of these? So this video was generated from a script. Sorry, this image was generated from a script with their corresponding audios. And then after that, we generated a video from it, which is this one, with its corresponding audio.
Takes us into the world of adding numbers. We will use something called a number line, which is like our secret map guiding us through the universe of numbers. Let's imagine you have 3 apples represented here by these small stones. Now let's add
So that was basically the video. And let me first take you through the model selection. So this table shows us the models that were used, the models that we selected, their purpose, their key strength, limitations, and also reason for selection. So we have the Phi-3 Mini 4K instruction, all Mini LM L6 V2 stable diffusion Google TTS with Tulip and MoviePy with their corresponding purposes, key strength, limitations, and reason for selection. Then for the models that the video that was generated was not perfect and it lacked motion. So we are looking into that. So that brings me to some of the limitations we found is that the generated images did not fully capture the exact meaning or instructional intent of the script. And with that, we're looking into fine-tuning the stable diffusion XL with Ugandan education and cultural like images to improve contextual accuracy. And then the other thing was that the voice generated in line with the local context, like the voice generated wasn't in line with the local context. So we are onto it to adapt the Google TTS with the local voice examples. And then the other thing was the generated images lacked motion in the video. So for that one, we are intending to integrate motion generation models, all having to create a model that does that. Then the other thing we encountered was limited resource, like the GPU, the GPU RAM, CPU RAM, and memory. We always ran into crashes because of the memory. So for that case, for now, we cleared memory after every output, but we are looking into beta models or even beta machines that could support these. So the pipeline successfully demonstrated how this model combining the text, images, video generation, how it can create education storytelling videos that is CBC aligned, while it needs more fine tuning. So our next steps include transforming those static images into animated sequences, conducting pilot studies with teachers and learners, also applying model quantization because we faced memory issues, and then also include regional languages like Luganda and Kiswahili. So we would like to thank a supervisor for their continued support and feedback. And then allow me take you through the code. The exploratory data analysis, this is the code. And for it, we're able to do some visualizations. Like I already explained, so this is basically the code. We looked into the data to understand how it looks like, to understand what kind of data we're working with. That we're able to run, this is the code. This is the code we used. So this is where we are finding issues with memory. And what we did for that is clearing memory every time we did. So this is where we generated a script, we generated the images, we generated the videos at last using that multimodal pipeline. That is all I had.